Hash table. The hash table data structure stores elements in key-value pairs where key, unique integer that is used for indexing the values. Value, data that are associated with keys. Hashing. In a hash table, a new index is processed using the keys, and the element corresponding to that key is stored in the index. This process is called hashing. Let k be a key and h of x be a hash function. Here, h of k will give us a new index to store the element linked with k. Hash collision. When the hash function generates the same index for multiple keys, there will be a conflict about what value to be stored in that index. This is called a hash collision. We can resolve the hash collision using one of the following techniques. Collision resolution by chaining, open addressing by linear or quadratic probing and double hashing. Collision resolution by chaining. In chaining, if a hash function produces the same index for multiple elements, these elements are stored in the same index by using a doubly linked list. If J is the slot for multiple elements, it contains a pointer to the head of the list of elements. If no element is present, J contains nil. Pseudocode for operations. Chained hash search searches for an element with key k in the hash table T by returning the element at the index h of k. Chained hash insert inserts the element x into the hash table T by setting the element at the head of the linked list at index h of x dot key to x. Chained hash delete deletes the element x from the hash table T by setting the element at index h of x dot key to nil. Open addressing. Unlike chaining, open addressing doesn't store multiple elements into the same slot. Here, each slot is either filled with a single key or left nil. Different techniques used in open addressing are linear probing, quadratic probing, double hashing. Linear probing. In linear probing, collision is resolved by checking the next slot. H of ki equals the quantity h dash of k plus I, modulo m. I is the set of non-negative integers starting from 0. H dash of k is a new hash function. If a collision occurs at h of k0, then h of k1 is checked. In this way, the value of I is incremented linearly. The problem with linear probing is that a cluster of adjacent slots is filled. When inserting a new element, the entire cluster must be traversed. This adds to the time required to perform operations on the hash table. Quadratic probing. It works similar to linear probing, but the spacing between the slots is increased more than 1 by using the following relation. H of ki equals the quantity h dash of k plus c 1 times I plus c 2 times I squared, modulo m. C1 and C2 are positive auxiliary constants. I is the set of non-negative integers starting from 0. Double hashing. If a collision occurs after applying a hash function h of k, then another hash function is calculated for finding the next slot. H of k I equals the quantity h1 of k plus I times h2 of k modulo m. Good hash functions. A good hash function may not prevent the collisions completely. However, it can reduce the number of collisions. Here, we will look into different methods to find a good hash function. Division method. If k is a key and m is the size of the hash table, the hash function h is calculated as h of k equals to k modulo m. For example, if the size of a hash table is 10 and k equals to 112, then h of k is equal to 112 modulo 10, resulting in a final value of 2. The value of m must not be the powers of 2. This is because the powers of 2 in binary format are 1, 0, 1001000. Likewise, when we find k modulo m, we will always get the lower order p bits. Multiplication method. The hash function h applied to k is equal to the floor of m times the quantity of k times a modulo 1. K times a modulo 1 gives the fractional part of k times a. Double L signs gives the floor value. A is any constant. The value of a lies between 0 and 1. But an optimal choice will be the square root of 5 minus 1 divided by 2, suggested by Knuth. Universal hashing. In universal hashing, the hash function is chosen at random independent of keys. Applications of hash table. Hash tables are implemented where constant time lookup and insertion is required, cryptographic applications, and indexing data is required.